Tonight, we're embarking on a journey that will reshape one of the most fundamental perceptions rooted deep in our minds, that unshakable belief about our place in the universe. Before looking up at those distant lights in the sky, let's first turn our gaze down to what's beneath our feet, this ancient ground we walk upon. Our goal isn't to discover how big Earth is, but rather to understand how small, how fragile an island it truly is in the silent, dark ocean of the universe. But this discovery goes far beyond a simple comparison. Before we talk about the colossal shadows of the Sun or Jupiter, we need to feel the scale of our own reality, that true scale where Earth becomes nearly invisible. Because there's a truth most of us haven't realized. Earth isn't just small, it's a microscopic existence, so tiny that words fail to describe it. By the end of this journey, we'll see our planet and ourselves under a completely different light. If you find peace in these kinds of quiet journeys that empty your mind and deeply affect how you perceive reality, consider subscribing to our channel and liking this video if you haven't already. Your silent support helps these profound explorations reach more curious minds. Now clear your mind of the noise of daily life and surrender yourself to the void. Let's begin. Our journey starts with our home, Earth, the place where we breathe and take our steps every day. From our surface perspective, Earth appears infinite to us. Even if someone spent their entire life traveling, they wouldn't have time to see every corner of this planet. Continents stretch for thousands of kilometers. Oceans disappear beyond the horizon, and massive peaks like Everest climb nearly 9 kilometers upward as if trying to pierce the sky. This sense of vastness is a biological illusion because we're no different from ants on this planet's surface. To our prehistoric ancestors, Earth was everything. In their eyes, the universe consisted only of Earth. The sky above their heads was like a dome with lights sprinkled upon it. The ground beneath their feet was flat and stretched infinitely in every direction. Based on what they saw, reaching this conclusion was perfectly logical. When you look at the horizon, Earth really does appear flat. The spherical curve is too subtle to notice unless you ascend to the uppermost layers of the atmosphere. Earth possesses a width that exceeds the limits of human perception. To visualize this vastness in our minds, let's do a thought experiment. If you wanted to walk along the equator and could somehow walk over the oceans too, you'd need to cover approximately 40,000 kilometers. Assuming you walked at average human speed for 8 hours a day without stopping, it would take more than 3 years to return to your starting point. This is an endless, exhausting, long lap around a single planet. On a human scale, Earth is truly massive and dizzying in its magnitude. Let's go one step further and think about the area of this enormous surface. Earth's surface area is approximately 510 million kilometers squared. To grasp this magnitude, think of it this way. If you wanted to visit every single square kilometer on Earth and stayed at each spot for just 1 second, even without sleeping or stopping, this journey would take more than 15 years. Massive countries like the United States or China are just small pieces next to this whole. They cover less than 2% of the total surface. Our eyes and perceptions whisper to us that Earth is infinite. But the nature of reality begins to shatter the moment we change our viewing angle. When we rise even slightly from the ground into that velvet darkness, our home, this massive sphere, starts to shrink. Not physically, but in meaning and significance. Earth stops being everything and becomes just one of many things. As we ascend, oceans become stains, continents turn into vague spots on a map. And we don't stop here, but continue pulling back into that silent void until Earth becomes nearly impossible to distinguish in that dark ocean. Now we're heading to the first stop of this cosmic shrinking, toward that pale gray guardian closest to us. Our first stop is the Moon, our nearest neighbor in the cosmic ocean. When we look at the sky, sometimes we feel it so close, as if we could reach out and touch it. Its bright surface has been an unchanging part of our nights since childhood. But this sense of proximity is just an optical illusion against the true scale of space. The distance between Earth and its satellite is a massive void that challenges the limits of human perception. This average distance of 384,000 kilometers is a chasm that Apollo astronauts could only cross in a 3-day journey, even with the fastest rockets. If you could continuously circle Earth 10 times without stopping, only then would you have traveled far enough to reach the Moon. The most striking way to visualize this distance is to compare the sizes of these two celestial bodies. If we reduced Earth to the size of a standard basketball, the Moon would be about the size of a tennis ball. In most textbooks or drawings, these two balls are depicted almost touching each other, but reality is far more desolate. If you wanted to place the basketball-sized Earth and tennis ball-sized Moon at the correct scale, you'd need to fit exactly 30 more Earths between them. That void, that distance of 30 Earths, consists entirely of silence and nothingness. This is the universe's first and most important lesson about how space is largely composed of emptiness. Even in our own cosmic backyard, the distances between objects are incredibly vast compared to their sizes. The Moon itself isn't actually an ordinary satellite. Compared to other planetary satellites in the solar system, it's surprisingly large relative to its parent planet. Its diameter is more than a quarter of Earth's diameter. This ratio is so high that some astronomers describe the Earth-Moon system as a binary planet system. This size means the Moon isn't just a dead rock hanging in the sky. It's a silent architect shaping Earth's destiny. The tides we see in our oceans every day are the Moon's gravitational breathing upon our planet. Oceans rise and fall in response to the Moon's pull. This rhythm has accompanied the heartbeat of life on Earth for billions of years. More importantly, the Moon is like an invisible hand keeping Earth's axial tilt balanced. If it weren't there, our planet could wobble like a drunken top around its axis. This could cause climates to change chaotically, poles becoming equators, equators becoming poles. We owe the delicate climate balance necessary for complex life to develop largely to this pale gray guardian. Another interesting coincidence in the sky is that the Moon and Sun appear almost the same size in our sky. The Sun is approximately 400 times wider than the Moon, but it's also approximately 400 times farther away than the Moon. This cosmic geometry allows the Moon to perfectly cover the Sun, creating total solar eclipses. But this perfect alignment is temporary, because the Moon is slowly but steadily moving away from us. Every year, it's leaving our planet at approximately 4 centimeters, the rate at which your fingernails grow. Millions of years ago, the Moon appeared much larger and more menacing in the sky. Back then, Earth's rotation was much faster, days were much shorter. Perhaps a day lasted only 5 hours. The Moon's pull has braked our planet's rotation, lengthening days and gifting us our current 24-hour rhythm. But in time's relentless flow, our faithful satellite continues to drift slowly into darkness. For now, it's our closest companion, the first and only place where humanity has pushed its limits and set foot on the surface of another world. But even this proximity will remain just a microscopic detail against the crushing magnitude of the Sun we're about to encounter. Now we turn our gaze to the source of life and simultaneously to that massive fireball where Earth's true smallness becomes dramatically apparent for the first time. When we turn our eyes to that colossal fireball, the source of life, the sun, all our perceptions about Earth's scale instantly become invalid. The sun is the sole reason for our existence. Without its light and heat, Earth would be no different from a frozen dead rock adrift in the void of space. But the sun isn't just a life-giving star, it's also a massive reference point that throws in our faces just how insignificant Earth's physical dimensions are on the cosmic stage. This star's diameter is so wide that you'd need 109 Earths lined up side by side to stretch from one end to the other. But diameter is a pale comparison next to volume. The truly dizzying reality is how much can fit inside this giant sphere. If the sun's interior were a hollow sphere and we tried to fill it with Earth-sized marbles, we'd need approximately 1.3 million Earths to fill this sphere. Visualizing this number in your mind is nearly impossible. Think for a moment. The depths of oceans, the breadth of continents, Everest's peak, all cities, billions of people, and our planet's billions of years of geological history. All of this isn't even a millionth of a speck of dust compared to the sun's volume. Every war, every discovery, every love, and every tragedy in human history has occurred on a microscopic piece that gets lost inside this massive ocean of fire. In this neighborhood we call the solar system, almost all matter belongs to the sun. 99.86% of the total mass in our system, that is, all the planets, moons, asteroids, and comets combined, is concentrated in the sun. Everything that remains, including giants like Jupiter and ringed wonders like Saturn, consists of only 1,000th of leftover material. From a gravitational perspective, the solar system actually consists of the sun and a few insignificant dust particles orbiting around it. We're invisible creatures on one of those dust particles. The distance between us and this massive mass is just as unsettling as the dimensions. The sun is approximately 100 million kilometers away from us. We call this distance 1 astronomical unit. This distance is so great that even light, the universe's speed limit, struggles to traverse this path. A beam of light leaving the sun needs to journey through the void of space for 8 minutes and 20 seconds to touch our faces. If the sun suddenly vanished right this second, we wouldn't notice for more than 8 minutes. It would still appear to shine in the sky. Gravity would continue holding us in orbit. We actually see not the sun's current state, but its past from 8 minutes ago, a kind of ghost. If we try to grasp this distance on a more human scale, the situation becomes even more striking. If you could drive toward the sun in a car going 100 kilometers per hour on a highway without ever stopping, it would take more than 170 years to get there. A human lifetime wouldn't suffice to complete this journey. Even humanity's fastest vehicles must perform complex orbital maneuvers lasting months just to reach this fiery giant's vicinity. The sun is everything to us, but in the universe at large, it's an ordinary middle-aged star classified as a yellow dwarf. It's been burning for approximately 4.6 billion years and has fuel to continue burning for about that much longer. Every second, it converts 600 million tons of hydrogen into helium, releasing tremendous energy. The mass it loses and the energy it produces in this process is billions of times more than all the energy humanity has ever produced throughout its history. Its surface is 5,500 degrees Celsius, while its core is a hell of millions of degrees. And we orbit this nuclear furnace in precisely that delicate zone, the Goldilocks region, where water can remain liquid, neither close enough to be scorched nor far enough to freeze. But even this safe distance doesn't change the fact of how fragile a refuge we live in compared to the rest of the universe. The sun's calm, warming face in the sky is actually a mask hiding the tremendous violence it conceals in its depths. This star isn't just a hot ball of gas, it's a nuclear furnace crushed under its own gravity, constantly exploding. The pressure at its center is hundreds of billions of times greater than Earth's atmospheric pressure. This incredible compression changes the nature of matter and hurls unimaginable amounts of energy into the void of space every second. While the surface temperature is expressed in thousands of degrees, in the core, this number reaches millions. What we know as sunlight is actually the calmed energy that, after thousands of years of journeying from this nuclear chaos, reaches the surface and escapes into space. The sun doesn't just radiate light and heat, it also spews matter. Through events we call solar flares and coronal mass ejections, it hurls massive pieces of its own atmosphere into space. When these plasma clouds reach Earth, they collide with our planet's magnetic shield. The mesmerizing auroras, northern lights, we see at the poles, are actually a visual feast of the sun's deadly breath being deflected by our planet's shield. Though this dance of light offers aesthetic beauty, it's actually a silent reminder of how dangerous the sleeping giant beside us can be. A power capable of instantly silencing our modern technology, satellites, and electrical grids awaits ready at any moment in the heart of our life source. For centuries, humanity struggled to accept that it revolves around this power. When we looked at the sky, we thought everything, even the sun, revolved around us. We placed ourselves at the center of the universe, at existence's most precious point. But cosmic reality shattered this arrogance. With the courage of thinkers like Copernicus and Galileo, we learned that Earth isn't a throne standing fixed at the center, but an ordinary piece of stone orbiting a massive star. This was humanity's first great lesson in universal-scale humility. Now we know that we're not the rulers, but merely passengers who are part of this system. When we look at the architecture of this system, the inner solar system, we see that Earth isn't alone, but its family is quite small too. This is the home of rocky planets, terrestrial worlds. At the very bottom of the sun's massive gravitational well, closest to the fire, 4 sibling planets line up: Mercury, Venus, Earth, and Mars. This quartet is tiny compared to the gas giants in the rest of the system. They all have solid surfaces composed of metals and rocks. This region is quite cramped on a cosmic scale. All 4 planets are clustered in relatively close orbits to the Sun. Until we reach that great void between Mars and Jupiter, the system appears crowded and dense. But even this proximity is deceptive. The distances between planets are still millions of kilometers. Going from one to another takes minutes even at light speed. Mercury is closest to the Sun, a world of extremes with its scorched and frozen surface. Right after comes Venus, a mysterious neighbor shrouded in a thick, suffocating atmosphere. Then our blue marble, floating in that miraculous orbit where water can stay liquid. And finally, Mars, the rusty planet where rivers once flowed but has now turned into a cold desert, marking the boundary of the inner system. Although each of these rocky worlds was born from the same dust cloud around the same star, their fates have been drawn completely differently. Some lost their atmospheres, some choked on greenhouse gases, some froze to death. Among these siblings, Earth shines like the only oasis harboring life, a product of lucky coincidence and delicate balances. But the stories of the other worlds surrounding this oasis whisper to us about how merciless the universe can be, and how precious Earth's balance truly is. Now, to take a closer look at these scorched and silent neighbors, we descend to that first orbit toward the Sun, where the heat is unbearable. Where the Sun's searing breath is most intensely felt, Mercury stands. With its crater-pocked surface, this small, dense planet resembles the Moon at first glance. But this is an entirely different world where silence and desolation reign. Mercury has virtually no atmosphere. It lacks an air layer to wrap around it, distribute heat, or protect against meteorites. This deficiency makes it a planet of extremes. While the side facing the sun heats up enough to melt lead, the dark side in shadow surrenders to the freezing cold of space. If you stood here and looked at the sky, you'd see the sun 3 times larger and much more frighteningly bright than it appears from Earth. But with no atmosphere, the sky wouldn't be blue. Even with the sun overhead, it would be pitch black and starry. The concept of time on Mercury is completely outside the rhythm we're used to. This planet completes its tour around the sun in 88 Earth days, so 1 year is quite short. But it rotates around its own axis so slowly that the time between one sunrise and the next is longer than the planet's year. Here, a single day lasts 176 Earth days. If you could walk on Mercury's surface, you'd see the sun pause in the sky, sometimes even move backward, set, and then rise again. This strange dance of time has continued unchanged on the planet's scorched rocks for millions of years. Moving slightly away from Mercury, we encounter that dazzling jewel shining in the void of space, Venus. Because it's one of the brightest objects in the sky, it's been given romantic names like Shepherd's Star or Morning Star. Its size and mass are so similar to Earth that astronomers long viewed it as Earth's twin. But this similarity is only a superficial deception. Venus is more like a dark reflection of its sibling than a twin. For any probe daring to land on its surface, this is the solar system's most merciless hell. The atmosphere surrounding Venus is a thick, suffocating blanket made of carbon dioxide. This layer is so dense that the surface pressure is exactly 90 times that of Earth's sea level. This is equivalent to feeling the weight of tons of water pressing on you at a depth of 1 kilometer in the ocean. This dense atmosphere is covered with sulfuric acid clouds. The rains here aren't water, but acid that can dissolve skin and metal. But the surface is so hot that these acid droplets evaporate before reaching the ground. Despite being farther from the sun than Mercury, Venus is much hotter. A runaway greenhouse effect has turned the planet into a heat trap. Surface temperatures reach an average of 470 degrees Celsius. This temperature is nearly the same everywhere, whether night or day, poles or equator. Heat is trapped inside the thick atmosphere and can never escape into space. Venus hangs in space as a terrifying proof of what can happen when a planet's atmospheric balance is disrupted. The planet's peculiarities aren't limited to its atmosphere. Unlike other planets, Venus rotates in the opposite direction. If you could see the sun there beneath those thick clouds, you'd witness it rising in the west and setting in the east. And this rotation is so slow that a day on Venus is longer than a Venus year. It takes more time to spin around its own axis than to orbit the sun. It's as if billions of years ago, a massive impact both slowed it down and flipped it upside down. Now, beneath those poisonous clouds, it continues spinning in its own reverse rhythm in silent, deadly solitude. The final stop of the inner solar system is Mars, the planet of red dust and frozen dreams. In complete contrast to Venus's suffocating dense atmosphere, this is a cold desert with a paper-thin air layer. Though called Earth's little brother, it's physically quite small compared to us. Its diameter is almost half of Earth's. If we could hollow out our planet's interior, we'd need 7 Marses to fill that volume. This size difference also means weaker gravity. Someone walking on Mars's surface would feel much lighter than on Earth. Their steps would be longer and more effortless. Mars has a melancholy story. The dried riverbeds, massive canyons, and ancient lake basins on its surface whisper that this place was once also a blue and wet world. Billions of years ago, rivers flowed on Mars, rains fell, and perhaps shallow oceans rippled. But the landscape we see today is endless aridity covered with rusty iron oxide dust. Even in the equatorial regions, temperatures rarely rise above freezing. At the poles, permanent white caps made of carbon dioxide and water ice are like last memories from the planet's old days. What changed this planet's fate and turned it into a desert was losing its invisible shield. The molten iron ocean spinning in Earth's heart creates a massive magnetic field that protects us from the sun's harmful particles. Mars once had such a shield too, but because the planet was smaller, its core cooled and solidified much faster than Earth's. When this internal dynamo stopped, the magnetic shield collapsed too. Once the protective shield was gone, winds from the sun slowly swept away the atmosphere, atom by atom, into space. This erosion, lasting millions of years, destroyed Mars's thick atmosphere. Waters evaporated or retreated underground and froze. All that remained was a thin, poisonous air with surface pressure only 1% of Earth's. Unbreathable. Two strange objects, unlike our moon, orbit in Mars's sky: Phobos and Deimos. Though their names mean fear and terror, these are actually shapeless, small rock fragments. They probably didn't form with Mars, but are rogue asteroids that escaped Jupiter's gravity and were captured by Mars's orbit. Phobos especially, just 22 kilometers wide, is a lumpy, potato-shaped rock. It's so close to Mars that it orbits the planet 3 times a day. If you stood on Mars's surface and looked at the sky, you'd see Phobos rising in the west and quickly setting in the east. But this proximity is preparing Phobos's end. Getting slightly closer to Mars each year, this small satellite will either break apart to form a ring around the planet or be destroyed by crashing into the surface in about 50 million years. These small, shapeless satellites are actually the first signs of that desolate region approaching. Beyond Mars's orbit, the familiar planetary order ends, giving way to a massive void where billions of rock fragments drift silently. This is that wide chasm between Mars and Jupiter, the scattered kingdom of building blocks that never came together to form a planet. This is where the rocky inner planets end. The reign of the gas giants hasn't yet begun. The deep border between these two regions is drawn by the belt formed by these countless stone fragments. Leaving behind Mars's thin atmosphere and rusty surface, a massive darkness opens before us. This is that great chasm between the warm worlds of the inner planets and the frozen giants of the outer system. The distance between Mars and Jupiter is so wide that it covers an area large enough to contain all the previous planets of the solar system. Within this void, millions of stone fragments, left over from our system's formation that failed to become a planet, drift silently. This region we know as the asteroid belt is like the abandoned remains of a cosmic construction site. The asteroid belt image that forms in our minds is usually shaped by the illusions created by science fiction films. In movies, spaceships pass through a dense rock storm where they must constantly maneuver to avoid collisions. But reality is far different from this chaotic scene and much more desolate. Space is literally empty. Even in the asteroid belt, the distances between materials are so great that if you stood on an asteroid and looked around, the only thing you'd see would be pitch darkness and distant stars. The nearest neighboring asteroid would probably be too far away to see with the naked eye, millions of kilometers away, remaining as a pale dot. The total mass of objects in this region is surprisingly less than expected. If we gathered millions of rocks, metal, and ice fragments into a massive scale, their combined weight wouldn't even reach 4% of the Moon's mass. So this isn't a graveyard of a shattered giant planet. It's a pile of dust that was never allowed to coalesce due to gravitational effects. If you passed through this belt on a random route, your chance of hitting a rock would be nearly zero. When passing spacecraft through this region, we don't worry about them hitting something. Rather, we must make very precise calculations so they can approach an asteroid for examination. In this desolate field of stones, there's one object that stands completely apart from the others, large enough to be considered a world in its own right: Ceres. This silent queen of the asteroid belt isn't a shapeless rock fragment. Its own gravity is powerful enough to have shaped it into a perfect sphere. At approximately 940 kilometers in diameter, it alone comprises 1/3 of the total mass of all other objects in the belt. That's why it's no longer classified as just an asteroid, but as a dwarf planet. With a surface as wide as the state of Texas, Ceres is a lonely world spinning in this dark void. What makes Ceres truly fascinating isn't just its size, but the secret it hides beneath its shell. The Dawn spacecraft that reached this distant world in 2015 presented us with an unexpected scene. There were mysterious glowing white spots and frozen volcanoes on Ceres' surface. But more importantly, we found evidence that beneath this small world's icy shell, it stores tremendous amounts of water. According to some estimates, Ceres' reserves may contain more fresh water than all of Earth's rivers and lakes combined. So far from the sun, in a region too cold for water to remain liquid, the possibility of a salty subsurface ocean changes how we look at the universe. Ceres isn't just a dead rock, but an intermediate world, one that may still be geologically active, harboring secrets in its depths. Between Mars's aridity and Jupiter's gas storms, this region where water is trapped in ice and rock serves as a frozen archive of the solar system's history. Here, time flows more slowly. Collisions occur once every millions of years, and the sun has begun turning from a warming fireball into merely a very bright star in the sky. Passing through the asteroid belt's sparse field of stones, we come face to face with the true ruler of the solar system. Before us appears Jupiter, hanging in the darkness like a massive striped sphere. It's not just a planet, but the master of an entire system in itself. Its dimensions are large enough to challenge the limits of the human mind. Its diameter is 11 times that of Earth. But this number alone isn't enough to convey its true majesty. Jupiter's volume is so tremendous that you could fit exactly 1,321 Earths inside it. If Jupiter's interior were a hollow sphere, you could throw all the other planets in the system, Saturn, Neptune, Mars, and everyone else inside it, and there would still be empty space left. This giant is like a gravitational monster. Excluding the Sun, it contains more mass than everything else in the system combined. This tremendous weight makes Jupiter the solar system's balancing point. It works like a massive vacuum cleaner, attracting rogue comets and asteroids wandering in the void of space. Throughout history, it has protected Earth from devastating collisions by attracting countless cosmic threats to itself or deflecting their orbits. Perhaps the reason we are here, breathing on this quiet night, owes itself to Jupiter's protective massive shadow. The planet's surface lacks solid ground. It's a gas ocean, constantly changing, spinning, and battling storms. The most famous of these storms is the Great Red Spot, staring at us like an angry eye in the planet's southern hemisphere for centuries. This is a massive anticyclonic storm, large enough to swallow all of Earth, spinning relentlessly. It's been churning there among those gas clouds for at least 400 years. Winds at its edges reach speeds of hundreds of kilometers per hour. But recent observations show this legendary storm is slowly shrinking. While it was once wide enough to devour 3 worlds, now it can only contain 1. This reminds us that even the most massive and seemingly permanent structures in the universe cannot withstand time's eroding effect. Jupiter isn't a lonely king. With at least 95 satellites orbiting it, it has its own miniature solar system. The largest 4 of these satellites have been known as the Galilean moons since their discovery by Galileo in 1610, and each is a world unto itself. The largest, Ganymede, is so massive it's even bigger than the planet Mercury. It's the only satellite known to have its own magnetic field. The family's most temperamental member, Io, is the most volcanically active body in the solar system. Caught between Jupiter's tremendous gravity and the pull of other satellites, Io is constantly stretched and compressed. This tidal effect heats the satellite's interior so much that its surface is covered with constantly erupting volcanoes and lava rivers. This is a hellish landscape painted with yellow sulfur plains and fire. The complete opposite is Europa. Its surface is covered with a smooth, crack-filled, pure white ice sheet. But beneath this frozen shell lies what's thought to be a deep, dark ocean containing twice the water of all Earth's oceans. Whether life nourished by Jupiter's tidal heat has sprouted in those deep waters where sunlight never reaches is one of modern science's greatest mysteries. As Jupiter and its complex family continue spinning in an endless dance of gas and dust, we turn our gaze to the system's next ringed marvel. In the outer rings of the solar system, the visually most captivating world awaits us. Saturn sits right behind Jupiter with its massive bulk. Its diameter exceeds 100,000 kilometers. You could fit 764 Earths inside this giant sphere. But what truly sets Saturn apart isn't its size, it's the rings that make it appear like a unique jewel hanging in the dark void of space. These rings consist of countless ice and rock fragments orbiting the planet. The fragments vary in size. Some are as small as a dust particle, others as large as an apartment building. The ring's width is tremendous. They extend thousands of kilometers from the planet's cloud tops. But despite this width, they're surprisingly thin. If we shrunk Saturn to the size of a basketball, the rings would appear thinner than a piece of paper. In most places, their thickness is only about 10 meters. This delicate structure has maintained its existence for billions of years through the precise balance of gravity and orbital mechanics. Scientists still debate these rings' age. Some say they were born with the planet. Others think they're much younger, perhaps remnants of a shattered ancient satellite. Saturn's surroundings are at least as crowded as Jupiter's. The planet has 146 known satellites. The largest of these is Titan. Titan has a diameter wider than the planet Mercury. Among hundreds of satellites in the solar system, it's the only place with its own dense atmosphere. In fact, its atmosphere is thicker than Earth's. Surface pressure is 1.5 times Earth's sea level pressure. This thick orange haze layer makes Titan's surface mysterious. Lakes and seas exist on Titan's surface, but they're not filled with water. It's too cold here for water to remain liquid. Temperatures drop to negative 180 degrees. That's why water here has turned into ice as hard as rock. Titan's seas are made of liquid methane and ethane. Hydrocarbon rains fall from the sky to the ground. These rains carve riverbeds and collect in low areas. This is the only place known to harbor stable liquid bodies on its surface besides Earth. This is like a much colder, chemically different version of Earth. Another remarkable member of Saturn's family is Enceladus. This small satellite is only 500 kilometers wide, covered with a pure white, fresh ice sheet. It reflects sunlight like a mirror. But what makes Enceladus special are the geysers at its south pole. Water vapor and ice particles constantly spray into space through cracks in the icy shell. This indicates the presence of a liquid ocean beneath the surface. The Cassini spacecraft passed through these geysers and conducted analyses. The results are exciting. Organic molecules, the building blocks of life, were found in the water. This small, cold satellite quietly spins in the shadow of the gas giant as one of the places with the highest potential for harboring life. Leaving behind Saturn's ringed magnificence, only deep darkness stretches before us. The sun is no longer a warming fireball in the sky. It's just a very bright, distant star. Light diminishes. Temperature approaches absolute zero. In this silent, frozen region dwell the solar system's ice giants. Our first stop is Uranus. Hanging in the void with its pale blue color, it resembles a massive sphere of ice. It's not as large as Jupiter and Saturn, but it still makes Earth look like a dwarf. Its volume is so vast you could fit 63 Earths inside it. Uranus is the solar system's strangest planet. All other planets spin upright or slightly tilted like a top. Uranus, however, is completely lying on its side. Its rotation axis is nearly parallel to the orbital plane. It's as if it's rolling forward through the void of space rather than spinning. This odd tilt is probably the result of a cosmic catastrophe billions of years ago. Perhaps an Earth-sized object struck young Uranus and toppled it. This sideways position causes extreme seasons on the planet. One of the poles faces the sun directly for part of its orbit, while the other pole is plunged into pitch darkness. Here, a season lasts exactly 21 years. If you lived at one pole, you'd see 42 years of uninterrupted sunlight, followed by 42 years when the sun never rose. A night lasting generations, and a day lasting generations. Uranus is a silent, cold world where time and light are experienced at extremes. Moving even farther, we reach the solar system's last known planet, Neptune. It's the most distant sentinel of the Sun. Its orbit takes so long to complete that one Neptune year equals 165 Earth years. This planet was discovered in 1846. From its discovery day to today, it's only completed one full lap around the Sun. Here, time is too slow to be measured by human lifespans. Neptune is a more vibrant, deeper blue than Uranus. But this beauty is deceptive. This is the windiest place in the solar system. Atmospheric storms blow at terrifying speeds. Wind speeds can reach 2,000 kilometers per hour, faster than the speed of sound. Even Earth's most violent hurricanes seem like gentle breezes next to Neptune's winds. Like Jupiter, giant storms form here too. Dark, massive spots appear in the atmosphere, then mysteriously disappear. The sun is so far from here that even at midday, it would seem like twilight to us. Light is faint, there's no heat. Neptune's internal structure has adapted to this cold. Over a rocky core lies a hot, dense ocean of water, ammonia, and methane. But this isn't an ocean in the way we understand it. It's a strange electrically conductive liquid compressed under high pressure. Neptune also has a family of satellites. The largest is Triton. Triton moves opposite to the planet's rotation direction. This reverse orbit shows it wasn't born there. Triton was probably a visitor from the depths of space, from the Kuiper Belt. It was captured by Neptune's gravity and trapped in orbit. But this captivity won't last forever. Triton is slowly approaching the planet. In the distant future, Neptune's gravitational force will tear it apart. Then, Neptune, like Saturn, will have a magnificent ring system. But for now, it continues spinning at the system's edge as a windy, lonely giant. Passing beyond Neptune, the familiar order of planets ends. For a long time, we thought this place was just empty void. But hidden in the darkness is a massive structure spread across billions of kilometers, the Kuiper Belt. This is like a frozen archive where primitive materials left over from the solar system's formation have collected. It resembles the asteroid belt between Mars and Jupiter, but it's much wider, and the objects within it consist mostly of ice rather than rock. Methane, ammonia, and water ice have gone into an endless winter sleep here. The most famous resident of this cold realm is undoubtedly Pluto. From its discovery in 1930 until 2006, we knew it as the ninth and final planet of the family. But when astronomers discovered thousands of objects like Pluto exist in this belt, they had to change the definition. Pluto is now classified as a dwarf planet. But this title change hasn't diminished its fascination one bit. Pluto is genuinely small. Its diameter is only about 2,370 kilometers, less even than Earth's satellite, the Moon. If we made Earth a basketball, Pluto would be smaller than a golf ball. It has a diameter about the width of the United States. You'd expect such a small world frozen 6 billion kilometers from the Sun to be a dead rock fragment. But when NASA's New Horizons spacecraft arrived there in 2015, humanity was met with a great surprise. Pluto was geologically alive. Massive mountains made of water rose on its surface, but at these temperatures, water ice was as hard as granite rock. Wide plains were covered with frozen nitrogen glaciers. These glaciers flowed just like Earth's glaciers, shaping the surface. A massive heart-shaped region on the planet called Tombaugh Regio existed, Pluto's frozen heart. It even had a thin blue atmosphere, glowing like a ghost in the sun's faint light. Pluto isn't alone in this darkness. It's accompanied by a faithful companion, Charon. Charon is quite large for a satellite, nearly half Pluto's size. These close sizes cause a unique dance between the pair. Charon doesn't orbit Pluto. Both spin around a common center of gravity located in the empty space between them. They're locked to each other. One face of Pluto always looks at Charon. The other face never sees it. This is one of the most romantic and melancholic waltzes in the solar system. There are other worlds in the Kuiper Belt besides Pluto and Charon. Eris is nearly the same size as Pluto, in fact, denser and heavier. Haumea has an odd egg shape and spins at a dizzying speed around itself. Makemake is another frozen world with a reddish surface. These are the large bodies we've been able to discover. But thousands of dwarf planets and trillions of comet nuclei that we still can't see are estimated to exist in the darkness. This is the solar system's crowded, cold, and mysterious backyard. From here, the sun is no longer warming, just a very bright point. The era of planets has closed. Now the only thing ruling is billions of years of silence and absolute cold. The Kuiper Belt is our system's visible last boundary. But it's not the end of our journey. Beyond this frozen junkyard stretches that ghostly region where the sun's gravity is weakest and begins mixing with interstellar void. Passing beyond the Kuiper Belt, far beyond Pluto's and other dwarf planets' orbits, we feel as if we've entered absolute nothingness. But this sense of emptiness is another trick the universe plays on us. The solar system's true boundary isn't where the planets end. Much farther out, At distances challenging our imagination, exists a cosmic shell surrounding our system like a massive sphere, the Oort cloud. This structure isn't a flat disk like the planets or asteroid belts we've seen before. The Oort cloud is a massive spherical bubble encasing the solar system from every direction, above, below, and from the sides. This is the outermost boundary of the Sun's domain. This massive sphere begins approximately 2,000 astronomical units from the Sun and extends nearly 2 light-years in distance. This is almost halfway to the nearest star, so the solar system's influence extends to a much wider area than we thought, deep into the depths of interstellar space. The Oort cloud is thought to contain trillions of icy objects. These are debris pieces ejected outward by the giant gas planet's gravity during the solar system's formation. For billions of years, they've been orbiting the Sun in extremely slow, long orbits at this dark boundary. Here, the Sun's gravity is so weak that these objects seem attached to the system by a cotton thread. A slight gravitational touch from another passing star or the general tidal check of the Milky Way is enough to disturb this balance. When this balance is disrupted, some of the icy bodies are scattered into the depths of space, lost forever. Others begin a fall inward toward the Sun that will last millions of years. The source of those long-period, magnificent comets we sometimes see in the sky is this distant, cold warehouse. The human eye has never directly seen any object in the Oort cloud. They're so far away, and objects are so faint that even our most powerful telescopes can't detect them. We know of their existence only through mathematical models and visitors coming from there into the inner system. This is the solar system's invisible wall, the final gateway to the unknown. When we stop at this point and look back at the path we've traveled, we're shaken by the solar system's mind-boggling scale. To grasp this magnitude, let's construct a model reducing everything to everyday objects. If we imagine the Sun as basketball-sized, Earth would be the size of a peppercorn sitting 26 meters away from that ball. Jupiter would be the size of a grape, about 130 meters away. The most distant planet, Neptune, would stand nearly 1 kilometer from the basketball. So where would the Oort cloud begin at this scale? The outer boundary of the Oort cloud would be thousands of kilometers from the basketball-sized Sun. So that 26-meter distance between Earth as a peppercorn and the Sun becomes microscopic compared to the system's total size. The solar system is a massive empire spread across trillions of kilometers, and Earth is just a tiny rock that has taken refuge in a safe harbor close to this empire's center. Within this massive volume, matter is so sparse that even the word emptiness falls short. Planets, moons, asteroids, and comets are no more than a few dust specks floating in this boundless dark ocean. Passing beyond the Oort cloud, the Sun's reign completely ends. Solar winds give way to the stagnant gases of the interstellar medium. The Sun now becomes an ordinary point of light, indistinguishable from other stars in the sky. This is where that great, silent, and cold ocean of interstellar space begins. Our home is no longer just a point. It's become a memory made invisible in this infinite darkness. Leaving behind the solar system's seemingly endless boundaries, the Oort cloud's ghostly ice, the scale of the universe changes skin once more. Now we step into a realm where we speak not of interplanetary distances, but of those terrifying chasms between stars, interstellar space. This is a massive ocean where distances lose meaning for the human mind, where kilometers or miles prove inadequate, where we can only measure using the speed of light. Our nearest neighbor star, Proxima Centauri, is approximately 4.24 light-years away from us. Though the term light-year sounds like a time unit, it's actually a distance measurement. Light travels at an unimaginable speed of 300,000 kilometers per second. The distance it covers in 1 year is approximately 9.5 trillion kilometers. Therefore, our nearest neighbor is about 40 trillion kilometers away. These numbers are so large they don't find correspondence in our minds. We just say very far and move on. But to feel the reality of this distance, we need to shrink the scale. Let's recall our earlier analogy. If we reduced that 150 million kilometer distance between Earth and the Sun to just 1 centimeter, about a finger's width, the nearest star, Proxima Centauri, would be approximately 6.5 kilometers away. That massive difference between a finger's width and 6.5 kilometers, that's the true size of the void between stars. Space is literally empty in every sense of the word. Stars are like grains of sand scattered with kilometers of separation in this dark ocean. Humanity's effort to overcome these distances is brave but equally melancholic. Voyager 1, launched in 1977, currently holds the title of humanity's most distant object. For nearly half a century, it's been traveling toward the depths of darkness at the tremendous speed of about 61,000 kilometers per hour. But despite the speed, Voyager 1 hasn't even covered a light day's distance yet. It needs to travel many more years to reach the distance light travels in 1 day. If Voyager 1 were heading directly to Proxima Centauri, which it's not, arriving there would take approximately 73,000 years. 73,000 years! This duration is many times longer than all of human history, from the times we drew pictures on cave walls to today. Even with our fastest spacecraft, going to the nearest star is a journey that will take not generations, but ages. If we had technology capable of reaching 10% of light speed, currently unimaginable, this journey would still take close to a half-century. From this point, the edge of interstellar void, when we turn back and look, Earth no longer exists. That pale blue dot within the solar system has been completely erased. Even looking with the most powerful telescopes, distinguishing Earth next to the Sun's brilliance is impossible. The Sun is no longer that massive fireball ruling the sky. It too is just one of countless bright points on the dark backdrop. Perhaps slightly brighter than the others, but it's become ordinary. At these distances, the concepts of here and there lose meaning. There's only infinite drift. Earth has vanished into invisibility with all its oceans, mountains, and cities. And let's not forget that Proxima Centauri is just our doorstep neighbor. Our journey into the galaxy's depths to other billions of stars hasn't even begun. Before us lie paths from Sirius to Betelgeuse, and from there to the Milky Way's heart, paths where even light grows weary. As we approach our nearest neighbor, Proxima Centauri, we see it's nothing like the Sun. It belongs to a star class called red dwarfs. Unlike those magnificent, bright stars we see in the sky, red dwarfs are small, faint, and cold. Its diameter is only 14% of the Sun's diameter. Its mass is about 12% of the Sun's. If we could place them side by side, Proxima Centauri would remain like a faint ember next to the Sun. But this smallness gives it a universal advantage. It uses fuel so slowly and frugally that its lifespan will last trillions of years. Long after our Sun exhausts its fuel and goes out, Proxima Centauri will still keep shining in the darkness. When the universe ages and all other lights go out, these small red stars will be the cosmos's final witnesses. But this long life doesn't mean a calm existence. Proxima Centauri is by nature a temperamental star. Violent flares frequently occur on its surface. These flare events suddenly increase the star's brightness and emit deadly radiation waves into space. Though we've discovered a planet called Proxima b orbiting in the habitable zone, these violent flares may have already destroyed any possible atmosphere there. Our nearest neighbor's home is an eerie place ruled by dim red light and sudden radiation storms. Leaving this dim neighbor and turning our gaze slightly farther, we encounter the night sky's brightest jewel. Sirius is 8.6 light-years away from us. This distance still counts as a doorstep neighbor on cosmic scale, but the void between is so tremendous that the light from Sirius we see today began its journey when an elementary school student on Earth today hadn't yet been born. Sirius is a blue-white star, much brighter and hotter than the Sun, but even it seems like a dwarf next to the true giants hidden in the galaxy's depths. To see how frightening scale can become, we need to direct our route to the Orion constellation, to that crimson star shining on the familiar hunter's shoulder, Betelgeuse. This is a red supergiant. It's approximately 700 light-years away from us. This distance reminds us once more how space and time interweave. When you look at the night sky and see Betelgeuse, you're not actually seeing its current state. The light you're seeing left the star when the Middle Ages were happening on Earth. While empires rose and fell, that beam of light silently crossed the void of space and only now reached your retina. Betelgeuse's truly shocking feature is its size. This star is so large that the human mind struggles to conceive it as an object. Its diameter is approximately 700 times the Sun's diameter. To make this number concrete, let's do a terrifying thought experiment. If we removed the Sun from its place and put Betelgeuse there instead, what would happen? Mercury would instantly be inside the star. Venus would be swallowed within seconds, and Earth with all its oceans, mountains, and history would evaporate and vanish in the depths of this red giant's atmosphere. The boundary wouldn't stop there. Mars would also descend into this giant's belly. Betelgeuse's edges would extend to Jupiter's orbit. The solar system's massive interior would be completely occupied by a single star's volume. At such scale, even talking about Earth's smallness becomes meaningless. Earth next to Betelgeuse isn't even a grain of sand. It's no different from a microscopic dust particle. And let's not forget that Betelgeuse isn't even the universe's largest star. Hypergiants like UY Scuti are large enough to eclipse even Betelgeuse. If UY Scuti were in the Sun's place, its boundaries would pass Saturn's orbit. Quadrillions of Earths would fit inside. These giant stars are proof of how the universe can process matter at extreme points. Some, like Proxima, are small and immortal. Some, like Betelgeuse, are massive and dying. Because the larger stars are, the faster and more violent their deaths. These giants wastefully consume their fuel and eventually collapse under their own gravity, turning into cosmic fireworks we call supernovae. Our Sun and the tiny Earth in its orbit continues its existence in an average, calm corner among these giants and dwarfs. Though stars' sizes astound us, what's truly surprising is their deaths, because when a star dies, the ghost it leaves behind fundamentally shakes our understanding of matter in the universe. These remnants are places where the relationship between size and mass pushes the physics we know to its limits, where density reaches mind-boggling levels. Middle-sized stars like our Sun don't explode violently when they exhaust their fuel. Instead, they quietly release their outer layers into space, leaving behind only their naked core. This is called a white dwarf. A white dwarf is approximately Earth-sized. Its diameter is about our planet's size, but half the Sun's mass is compressed into this small volume. Visualizing this condition in our minds is difficult. Imagine fitting hundreds of thousands of Earth's masses into an Earth-sized sphere. This compression creates tremendous density. A single teaspoon of matter from a white dwarf would weigh approximately 5 tons if weighed on Earth. This is like squeezing an entire elephant into a teaspoon. But the universe's compressing power isn't limited to this. When stars much larger than the Sun die, they collapse upon themselves and bid farewell to their lives with a supernova explosion. The remaining core is compressed so much that even the spaces inside atoms vanish. Protons and electrons merge, and a neutron star emerges. This object is more like a massive atomic nucleus hanging in space than a star. Neutron stars' sizes are shocking. Their diameter is only about 20 kilometers, meaning this star could fit within the boundaries of a city like Istanbul or New York. But nearly twice the Sun's mass is compressed into this tiny city. Density is so great that the human mind struggles to grasp it. A single teaspoon of matter from a neutron star would weigh approximately 4 billion tons on Earth. This is equivalent to reducing all of Mount Everest to the size of a sugar cube. Gravity here is so powerful that even a dust particle falling on the surface creates a nuclear bomb effect. The ultimate point of this collapse is black holes. When the most massive stars die, gravity wins an absolute victory over matter. Matter collapses to an infinite point and creates a region from which even light cannot escape. The Sagittarius A black hole at our galaxy's center has a mass 4 million times the Sun's, but the event horizon, that boundary of no return, is surprisingly small. Its diameter is only 17 times the Sun's diameter. So you've imprisoned 4 million suns in an area small enough to fit in the solar system's center. There are even bigger monsters. The black hole at the center of the M87 galaxy has a mass 6.5 billion times the Sun's. Its event horizon is wide enough to encompass our entire solar system. These cosmic tombstones show us that size doesn't always mean power. A neutron star is much smaller than Earth. It's city-sized, but with its mass and energy, it could instantly destroy Earth. A white dwarf is the same size as Earth, but millions of times heavier. These remnants remind us once more how empty the universe is. 99.9% of atoms within matter is empty space. Neutron stars are rare objects where this emptiness is removed. Earth is quite light and loose on this density scale. The rocks, mountains, and continents we call solid are actually sparse structures full of atomic voids. Next to these most dense, most extreme objects in the universe, rocky planets like Earth remain as light and delicate as feathers drifting in void. This violent and dense life cycle of stars is the most dramatic proof of how the universe processes matter. When we raise our heads to the night sky and look at that seemingly infinite sea of stars, we're actually looking at a very limited corner of the universe. Every star we can see with the naked eye, without exception, are all residents of a single city. This city is our galaxy, the Milky Way. Leaving behind the solar systems and nearby stars seemingly endless voids and pulling back to an even wider perspective, the landscape before us is breathtaking. The Milky Way is a massive spiral made of light, spinning in dark space. It harbors between 100 billion and 400 billion stars inside. The Sun is just one of billions of grains of sand in this boundless ocean of light. This structure's dimensions eclipse all the distances we've discussed before. Going from one end of our galaxy to the other takes a full 100,000 years, even at light speed. We're talking about a speed where light can circle Earth 7 times in 1 second. Even at this speed, a journey taking 100,000 years isn't enough to express the Milky Way's majesty. To visualize this scale in our minds, let's construct a model. If we reduced that massive distance between us and our nearest neighbor, Proxima Centauri, approximately 40 trillion kilometers, to about a finger's length, roughly 2.5 centimeters, the Milky Way galaxy's width would be approximately 600 meters in this model. This equals a massive skyscraper's height. The solar system in this model would remain smaller than a microscopic dust particle invisible to the eye. The Milky Way has an elegant shape called a barred spiral galaxy. At its center is a bright, flat bar structure composed of old stars. From this bar's ends, massive arms curve outward, extending into space's depths. We don't live in one of these main arms, but in a smaller intermediate extension called the Orion Spur. Our location is quite far from the galaxy's chaotic, crowded, radiation-filled center. We're approximately 26,000 light-years from the center. Speaking in cosmic real estate terms, we reside in the galaxy's suburbs, a calm, quiet neighborhood where stars are relatively sparse. This massive city of light doesn't stand still in space. It spins around itself at tremendous speed. But this rotation isn't like a solid wheel, it's like a fluid vortex. Stars closer to the center spin faster. Those outside spin at different speeds. Our Sun and its bound planets complete one full lap around the galactic center in approximately 225 to 250 million years. Astronomers call this massive time period a galactic year or cosmic year. When we compare this duration with Earth's history, time's depth makes our head spin. The last time the Sun was at its current position, in the previous galactic year, humans didn't exist on Earth. In fact, even mammals weren't around yet. In that era, dinosaurs were just beginning to appear on Earth. They weren't even the planet's rulers yet. Going back one more lap, the continents were joined. The single massive landmass Pangaea ruled. Earth is approximately 20 galactic years old. The universe itself is approximately 60 galactic years old. Human history, from the first pictures drawn in caves to today's modern skyscrapers, everything we've lived through fits into a tiny fraction of a second, an incomplete tick sound in this massive wheel's rotation. Our galaxy's structure isn't the same everywhere. Where we're located is a relatively safe refuge between two large arms, the Sagittarius and Perseus arms. These large spiral arms are active regions where gas and dust compress, new stars are violently born, and giant stars explode in supernovae. Our location in a calmer region between these arms perhaps allowed life on Earth to develop for billions of years without encountering a major cosmic catastrophe. We're observers in that quiet, dark corner of the galaxy's countryside, watching the light of billions of neighbors from afar. Departing from our galaxy's calm outer neighborhoods, its countryside, and embarking on an imaginary journey toward the center, the landscape changes dramatically. Those safe, dark voids between stars gradually narrow. When we enter the region called the galactic bulge, we've stepped into an extremely crowded metropolis where old orange stars rule. This is a dense, spherical structure approximately 10,000 light-years wide, where stars pile on top of each other. Star density in this region is incredibly high compared to the Orion Spur where we're located. On Earth, when we look at the night sky, we see the nearest stars separated by light years. But if you lived on a planet near the galactic center, the concept of night would have an entirely different meaning for you. Your sky would never completely darken. Thousands of stars shining overhead would each have the brightness of a full moon. The night sky would be as bright as twilight on Earth. with that dense light stars emit. You wouldn't need artificial light to read a book. The sky would appear like a constantly glowing, dazzling jewelry box. At the very center of this sparkling chaos lies a dark secret holding everything together, the heart of the Milky Way, Sagittarius A*. This is a supermassive black hole. Its mass is exactly 4 million times greater than our sun's. Imagine taking 4 million suns and compressing them into a relatively small volume. This massive mass is like an invisible maestro directing the gravitational traffic at the galaxy's center. We can't see the black hole itself because even light can't escape its pull, but we know its existence with certainty from its effects on surrounding stars. Stars in this region don't orbit in calm trajectories. Under the black hole's tremendous pull, they're hurled at dizzying speeds. For example, a star we call S2 completes its lap around this dark lord in just 16 years. At its closest point, its speed rises to 3% of light speed, moving at millions of kilometers per hour, a massive star making a sharp turn around an invisible point. This is one of the universe's wildest and fastest dances. The central region isn't just crowded, but also extremely noisy. But this noise isn't measured in sound, it's measured in radiation. Gas and dust clouds falling into the black hole heat up to millions of degrees from friction before entering the event horizon. This process emits dense amounts of X-rays and gamma rays into space. Additionally, magnetic fields here are extremely powerful and complex. Stars are so close to each other that sometimes they can scrape past each other's atmospheres. Even direct collisions can occur. This environment is extremely hostile to life. The dense radiation it emits can strip planets' atmospheres or sterilize their surfaces. Supernova explosions happen much more frequently here. The long, calm periods a planet needs to enter a biological evolutionary process are nearly impossible here. Our being 26,000 light-years from the galactic center is like winning a cosmic lottery. The galaxy's heart is visually magnificent and physically fascinating, but it's also a deadly radiation hell. We're lucky observers on the shores of calm waters far from this violent core, watching this tremendous show from a safe distance. Earth being located in such a boring, empty corner is actually our existence's greatest guarantee. Pulling back from the galaxy's chaotic center and the spiral arms where we're located to a wider, broader perspective, we discover that the Milky Way isn't just a flat plate or spinning disk. There's a much wider, older structure surrounding this glittering disk from every direction, the galactic halo. This is the galaxy's spherical periphery. Within it, gas and dust diminish, but a massive sphere keeps watch, containing the universe's oldest stars. This region is like an ancient city from the galaxy's first formation times. The stars here are cosmos's elderly witnesses, born when the Milky Way hadn't even formed that elegant spiral shape yet. Within this halo, structures resembling jewelry boxes randomly scattered through the void of space hang suspended. We call these globular clusters. Unlike open star clusters, these are massive glowing spheres where gravity has tightly knitted together hundreds of thousands or even millions of stars. One of these clusters is M13, shining approximately 22,000 light-years away in the direction of the Hercules constellation. M13 hosts more than 300,000 stars, packed into an area approximately 145 light-years wide. The density at M13 center is incomparably greater than the region where our Sun is located. If Earth were in the orbit of a star at M13 cluster's center instead of a lonely corner of space, we'd never know the concept of night. The sky would be so crowded that stars would appear to touch each other. When you raised your head, thousands of stars, each as bright as Venus in our sky, would turn night into constant twilight. Darkness would never fully descend. That window allowing us to see the universe's depths would close with stars' dense brilliance. At this density, stars colliding or disrupting orbits is much more likely. Our calm sky is actually a gift of cosmic solitude. But our galaxy's true mass and mystery aren't hidden in the shining spiral arms or these magnificent star clusters. Everything we see, billions of stars, massive gas clouds, and planets, is actually a very small portion of the Milky Way's real mass. There's an invisible skeleton holding our galaxy together, preventing stars from being scattered into space: dark matter. We can't directly see dark matter. It doesn't emit light, doesn't reflect light, and doesn't block light. It's a ghostly presence. But we know it's there because we feel its gravitational effect. Stars in the galaxy's outer parts spin so fast despite being very far from the center that normally they should be flung into space. The force holding them in orbit is a gravitational pull far greater than visible matter could provide. This invisible hand is dark matter. The Milky Way's visible disk is approximately 100,000 light-years wide, but the dark matter halo extends far beyond that, probably up to 600,000 light-years away. Our galaxy is actually a relatively small, bright island floating within a massive dark matter ocean. Most of the universe's matter consists of this mysterious structure. The normal matter we know, atoms, stars, planets, and us, comprises about 5% of the universe. The rest is this dark ocean whose nature we still can't fully understand. At this scale, when we turn back and look at Earth, our planet's importance diminishes once more. We're not just orbiting one of hundreds of thousands of stars in the Milky Way. We're also a tiny part of a massive invisible structure in which the galaxy itself is lost. Next to M13 cluster's dense star field, the solar system isn't even a dot. Against the dark matter halo's tremendous width, Earth shrinks to occupy less space than a subatomic particle. The universe has a magnitude that challenges our comprehension, both with its light and its darkness. Leaving behind the Milky Way's tremendous spiral arms, its shining billions of stars, and the dark matter halo surrounding it, and opening out to a deeper void, we climb another step in the universe's hierarchy. Our galaxy isn't a lonely island drifting alone in this infinite darkness. It's part of an archipelago, a cosmic family where other islands like itself exist. This structure astronomers call the local group consists of approximately 54 galaxies bound together by gravity. This group spans an area approximately 10 million light-years wide. Though it sounds massive, as we'll soon see in the universe's general structure, this is just our small neighborhood. We're not the largest member of this neighborhood. The Milky Way ranks second in the family in terms of size. The leadership seat is occupied by our massive neighbor sitting approximately 2.5 million light-years away, the Andromeda Galaxy. Also known as M31, Andromeda is much more majestic than the Milky Way. It hosts approximately 1 trillion stars, nearly twice the number of stars in our galaxy. Its diameter is also wider than ours, extending approximately 220,000 light-years. If the night sky were darker and our eyes more sensitive, we'd see Andromeda as a light patch 6 times wider than the full moon in the sky. It's the most distant object visible to the naked eye, a ghostly light coming from millions of years in the past. The local group's third largest member is the Triangulum Galaxy, M33. With approximately 40 billion stars, this spiral galaxy remains modest next to Andromeda and the Milky Way. Most of the remaining members are dwarf galaxies, small satellite clusters with just a few billion or million stars orbiting large galaxies like moths. For example, the Large and Small Magellanic Clouds visible in the southern hemisphere are the Milky Way's best-known dwarfs in orbit. But these small galaxies' fates are often melancholic. Large galaxies' tremendous gravitational pull slowly tears them apart, steals their stars, and eventually completely devours them. The Milky Way is currently busy digesting some small neighbors like the Sagittarius dwarf elliptical galaxy. But the group's most dramatic event isn't the swallowing of dwarf galaxies, it's the approaching rendezvous of two giants. While most galaxies in the universe are moving away from each other, Andromeda and the Milky Way are being pulled toward each other. Gravity's invisible ropes are bringing these two giants closer at approximately 400,000 kilometers per hour. This is an inevitable cosmic dance. In approximately 4.5 billion years, these two massive structures will collide. Though the word collision creates images of violent destruction in minds, what will actually happen is more of a merger. Galaxies are so empty that when two galaxies interpenetrate, the probability of stars physically colliding is nearly zero. They'll pass through each other like ghosts, be scattered by gravitational waves, and eventually merge to form a massive elliptical galaxy. If Earth still existed in that distant future, which isn't very likely due to the Sun's evolution, the sky would present an incredible spectacle. First, Andromeda's spiral arms would grow large enough to fill the entire night. Then, when the merger began, explosions in star formation regions would light up the sky like fireworks. The Milky Way's familiar band would dissolve, replaced by a chaotic and glorious sea of light. Two supermassive black holes would merge while performing a deadly waltz at the new galaxy's center, and we'd become residents of this new, massive home, perhaps Milkomeda. But for now, the local group behaves like a system isolated from the rest of the universe, closed in on itself. Intergalactic voids are tremendous even here, but this group is also just a small dot on the universe's true scale. The local group is just the central neighborhood of a larger structure, a massive cluster containing thousands of galaxies. The universe's fabric is woven in a more complex and interconnected web than we thought. This large family we consider massive is just one node in that massive web. Though the local group appears massive, on the cosmic map it's just like a small town. When we exit this town and rise to a wider perspective, we find ourselves inside a tremendous metropolis called the Virgo supercluster. This structure is approximately 110 million light-years wide. It contains at least 100 galaxy groups and clusters, including our local group. In total, more than 100 trillion stars shine within this massive volume. The heart of this supercluster is the Virgo cluster, approximately 54 million light-years from us. This is the central point of gravity, where galaxies are densely packed. The ruler of this center is the giant elliptical galaxy called M87. M87 doesn't have elegant arms like the Milky Way. It resembles a spherical ball of light. But this simplicity is deceptive. M87 is much more massive than the Milky Way and hosts trillions of stars. The supermassive black hole at its center is 6.5 billion times the Sun's mass. That famous black hole shadow, photographed for the first time in human history in 2019, belongs to this giant galaxy's heart. To grasp the scale at this point, let's resort to another analogy. If we reduced the Milky Way galaxy to a coin size, the Virgo supercluster would be the size of a large city. Our solar system, stars, planets, and everything we know would remain a microscopic scratch on that coin. But a discovery made in 2014 revealed that even this massive city is actually just a neighborhood of a much larger country. When astronomers mapped galaxies' movements through space and their gravitational flows toward each other, they faced a surprising truth. The Virgo supercluster was just a small extension of a massive structure with much wider boundaries. This new structure was named Laniake, meaning immeasurable heaven in Hawaiian. Laniake is a supercluster of superclusters. It spreads approximately 520 million light-years wide and contains 100,000 galaxies like ours. Laniake's structure resembles a living organism's nervous system or a web woven from bright light fibers. Galaxies are arranged along this web's threads. The Milky Way is located on a fiber quite far from this massive structure's center, near the outer boundaries. Laniake is so large that light takes more than 500 million years to go from one end to the other. A beam of light that began its journey long before dinosaurs even appeared on Earth still hasn't reached from one end of this structure to the other. This structure's most fascinating feature is that it's not static. All galaxies within Laniake, including the Milky Way, move like leaves drifting in an invisible river. We're all flowing toward a common center, a gravitational attraction point. Astronomers call this mysterious attraction point the Great Attractor. This region is such a dense area of space that it's pulling tens of thousands of galaxies toward itself. But because our own galaxy's dust and gas clouds block our view, we can't directly see what the Great Attractor looks like. We only feel its tremendous power, that irresistible invitation pulling us and millions of neighbors toward it. When viewed at Laniake's scale, the Milky Way galaxy is no longer even a coin, it's merely a faint speck of dust. Now the concept of place has completely faded. Only massive energy flows and galaxy rivers remain. The universe has a structure much more organized, much more fluid, and staggeringly tremendous than we imagined that paralyzes imagination. And we're drifting in the current at the edge of this structure. While trying to understand Laniake's glorious boundaries and the mystery of the Great Attractor pulling us toward it, an even larger reality's silhouette appears on the cosmic horizon. Recent observations show that Laniake and everything within it, even beyond the Great Attractor, is being dragged toward a much more tremendous mass. This new giant is the Shapley supercluster. Located approximately 650 million light-years away, its mass is so great it equals the weight of 10,000 trillion suns. It's the true winner of the gravitational tug-of-war in this corner of the universe. Laniake, the Great Attractor, and the Milky Way are all flowing together in a cosmic river toward this massive titan. But even these superclusters are merely building blocks of the universe's largest structure. When we look at galaxies' distribution at the widest scale, we don't see randomly scattered points. The universe has its own organic texture. Matter has organized into massive filaments and walls called the cosmic web. This structure resembles a giant spider web glowing in a dark room, or a brain cell's complex neural networks. We call this web's threads filaments. Galaxies, gas, and dark matter are arranged like pearls along these long threads. Laniake is just a single thread of this web. In the universe's depths, walls rise with dimensions challenging our imagination. One of these is the Sloan Great Wall, discovered in 2003. Approximately 1.37 billion light-years long, it's a massive wall woven from galaxies. In the model where we thought of the Milky Way as coin-sized, this wall would appear like a mountain range extending for kilometers. Even larger is the Hercules Corona Borealis Great Wall. This structure is so large that its discovery shook cosmological theories. It's approximately 10 billion light-years wide. This distance covers a significant portion of the observable universe's diameter. Whether the universe is old enough to form such a massive structure is even a topic of debate among scientists. Between this cosmic web's bright walls and threads lies terrifying nothingness. We call these cosmic voids. While gravity pulls matter toward filaments, it leaves behind nearly completely empty areas. These voids constitute 80% of the universe's volume. One of the best known, the KBC void, is approximately 2 billion light-years in diameter. These voids' interiors are the universe's most desolate places. If a planet were located at the exact center of such a void, the sky would be pitch black. The nearest galaxy or star cluster would be so far away that until telescopes were invented, we'd think we were alone in the universe. Voids cause us to liken the universe to a sponge. Matter is the sponge's filled parts, but most of the volume consists of those air-filled pores, nothingness. At the scale of this massive web, walls extending billions of light-years and infinite voids, describing Earth's smallness becomes impossible. Even the Milky Way galaxy is merely a microscopic knot within this web. Laniakea is just a thin fiber. Earth is a nearly negligible point in this cosmic weave, mathematically almost non-existent. On the universe's largest map, our existence doesn't occupy physical space. It takes up only as much space as a probability calculation. Wrapped in infinity's cold breath above that indefinite point, we continue spinning. When we unfold the cosmic web's massive filaments and the dark voids between them, we reach our journey's not physical, but perceptual limit. This is that ultimate wall where human knowledge and vision collide. The observable universe, this term refers not to the universe's entirety, but only to the part from which light has been able to reach us since the beginning of time. The universe is approximately 13.8 billion years old, but this doesn't mean the radius of the area we can see is 13.8 billion light-years. Because while light traveled toward us, space itself continued expanding. Due to this expansion, those distant galaxies that sent their light on its journey billions of years ago have now been swept much farther away. Consequently, the diameter of this massive visible sphere we're inside reaches approximately 93 billion light-years. This sphere's interior hosts a crowd that paralyzes imagination. Approximately 2 trillion galaxies are estimated to exist within the observable universe. 2 trillion separate islands. Each has billions of stars, countless planets, and nebulae like the Milky Way. When we try to add up all the stars in all these galaxies, the number we encounter is on the order of 200 sextillion. That means you need to put 21 zeros after the number 200. To visualize this number in your mind, think of all the beaches on Earth, all the deserts, the ocean floors. Imagine counting every single grain of sand on our planet. The number of stars in the universe is many times greater than the number of all sand grains on Earth. If each grain of sand is a sun, our sun is just one of billions of particles on that infinite beach. And Earth is merely microscopic dust orbiting that single grain of sand. But even this massive number and 93 billion light-year diameter isn't the story's end. The observable universe is only the part of the cosmos we can see. The question of what exists beyond our light horizon is one of science's most unsettling and fascinating mysteries. Beyond the horizon, probably more of the same we see, consisting of more galaxies, more stars, and more voids, continues in a massive area. So how big is this area? Some theories propose the universe is actually infinite. If the universe is infinite, that massive 93 billion light-year sphere we call the observable universe is nothing next to infinity. Mathematically, any finite number's ratio to infinity is always zero. In this case, everything we see, all those trillions of galaxies, comprises 0% of reality. In an infinite universe, possibilities also become strange. If matter and energy are spread across an infinite area, atoms' arrangement combinations must eventually repeat themselves. This means very far away somewhere there could be another solar system exactly like ours, another Earth, even a copy of you currently listening to these words. Infinity is not just magnitude, but also repetition. Other physics theories bring the multiverse concept to the table. There are physicists who think the Big Bang wasn't a single event, but just one of continuously occurring explosions within an eternal inflation process. According to this view, our universe is merely a single bubble in an infinite sea of foam. Elsewhere, countless other bubble universes with different physics laws, where light behaves differently and time flows differently, may exist. At this scale, from infinity's or the multiverse's perspective, describing Earth's smallness can no longer be expressed with a physical unit of measurement. The Milky Way galaxy shrinks to the size of a subatomic particle. Earth transforms into existential nothingness. This planet that's everything to us isn't even a drop of water in the cosmic ocean. It's no different from a mathematical point lost within infinity. But this sense of nothingness paradoxically makes our existence even more mysterious, because within this infinite, uncaring magnitude, somehow a consciousness capable of contemplating the universe emerged on a rock occupying less space than even a point. Peeling away from theoretical physics and infinity concepts to a concrete moment, let's return to one of humanity's most shocking visual documents. The date is February 14, 1990. Voyager 1, humanity's most distant object, has completed its primary mission and is rapidly moving away toward the solar system's dark boundaries. It's approximately 6 billion kilometers from Earth. This distance is so great that a radio signal sent from there takes hours to reach us. That day, engineers send one final command to the craft. Turn your camera back and take one last look at your home. Voyager complies with this command and takes that famous photograph. This frame shows space's deep darkness and pale light bands coming from the sun, and within one of those bands hangs a bluish dust particle so small you'd miss it if you weren't looking carefully. It's smaller than a pixel in size. That dot is Earth. All the maps, globes, and borders we've drawn become meaningless because in this photograph, Earth is no different from a single dust particle caught in sunlight drifting in a cosmic ocean. Famous astronomer Carl Sagan's deep reflection on it forever changed humanity's perspective. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of. Every human being who ever was lived out their lives there. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. This perspective throws in our faces how misplaced human arrogance is. Earth is a very small stage located in a vast cosmic arena. Look at that dot more carefully, and think about those great wars we read about in history books. Think about the rivers of blood spilled by self-proclaimed supreme generals and emperors to temporarily rule just a small fraction of that dot. Their victory cries or victims' lamentations cannot be heard from this distance. Think about that endless hatred harbored by those living in one corner of that dot toward people in another corner who are actually exactly like themselves. How deep are our delusions? How eager we are to kill each other. But viewed from space, no borders are visible, no flags. There's only a lonely planet. Our posturing, our imagined self-importance, and the delusion that we hold some privileged position in the universe is demolished by this pale point of light. Our planet is utterly alone in the vastness it's enveloped within. In this vastness, there's no hint that help will come to save us from ourselves. At least in the near future, there's nowhere else we can go. We can visit, yes, but settling elsewhere remains beyond our dreams. Whether we like it or not, for now, the only place we can live is Earth. This photograph proves that astronomy isn't just a scientific discipline, but also an experience of humility and character building. Perhaps no evidence can better demonstrate human arrogance's foolishness than this photograph taken from that distant distance. This image reminds us of our responsibility to treat each other more compassionately. It whispers our obligation to protect and value that pale blue dot, the only home we know. Because if that dot disappears, we disappear too. The human mind is evolutionarily programmed to grasp distances of a few kilometers or a tribe's population. We can't intuitively understand billions of galaxies, trillions of stars, or distances lasting light years. We can write the numbers on paper, do the mathematics, but we can't truly feel that magnitude. That's why Earth still seems big to us. Our problems seem massive, our conflicts seem inevitable. But Voyager's final look shows us the truth. Our problems don't matter to the universe. Our conflicts are invisible on cosmic scale. We're travelers who have taken refuge in the only candlelight we have in the middle of an infinite night, watching our surroundings with fear and curiosity. And that candlelight is much more fragile, much more delicate than we think. Tonight we took our minds to the universe's darkest corners, to those distant galaxies where even light grows weary, and finally returned here, to our home. The picture we saw is both unsettling and awe-inspiring. The universe is unimaginably vast, cold, and silent. Earth is almost negligible within this infinity. But the greatest lesson this journey taught us isn't just about dimensions. The real lesson is about what value means. Because magnitude isn't value's only measure. In that massive void of the cosmic ocean, trillions of dead rocks, burning gas balls, and frozen ice masses drift. But as far as we know, only on this small blue dot has matter transformed into something miraculous. Here, atoms have combined to form life. Life has evolved into consciousness. Earth is perhaps the only place where the universe can contemplate its own existence, observe itself, and marvel at its own magnitude. As you listen to these words right now, you're actually looking at itself as a part of the universe. This carries meaning much greater and deeper than dimensions. This sense of smallness doesn't have to be frightening. On the contrary, you can accept this feeling as great liberation. Think about the burdens weighing on your shoulders throughout the day, those big problems worrying you. Now place them next to those massive galaxy clusters, those billion light-year voids. They're all merely temporary tremors on a dust particle. In the universe's silent, uncaring flow, our anxieties, ambitions, and fears lose their weight. On this infinite stage, only the lightness of simply existing, breathing, and being able to watch this tremendous show remains. Now it's time to drape the peace this cosmic perspective brings over your weary mind like a blanket. No matter how complex the outside world becomes, you're in a safe harbor right now. This planet you're standing on has been spinning silently in the void of space for billions of years, carrying you. It's the only nest filled with life's warmth, the safest refuge among trillions of possibilities. When you close your eyes, imagine that infinite sky above your head. Billions of stars are shining there in the darkness. Each one is a distant sun illuminating its own planets, and most of those stars are sharing the same silence covering you right now. The universe's natural state isn't noise, but silence. Not chaos, but harmony. You too are part of this harmony, this great order. Your atoms were forged in the hearts of those stars billions of years ago. You're literally made of stardust, and now you're resting at home within that great cycle where you belong. Feel your breath slowing, your body surrendering to gravity. Just like Earth's effortless glide around the sun, you too let yourself go into sleep's soft void. There's nothing to rush, no place to reach. There's only this moment, this breath, and this deep peace. Earth will keep spinning, stars will continue shining, and the universe will keep writing its billions of years long story. Tonight, you're this story's most peaceful line. Let the thoughts in your mind fly off one by one toward those distant stars. As they move away, let them shrink, just like Earth's appearance from space. Let them fade and finally vanish into darkness. Let only silence remain. This vast, this ancient, and this peace-filled silence. The universe is very large, Earth is very small, but this is our home, and you're safe here. Now let all the stars shine for you, and let the night's velvet darkness wrap around you. Good night.